So the first example that I'm going to show you is using the substitution method. So one of the tricky things about solving systems is that there's so many different ways or methods that you can use to solve, and you have to pick which one will work best. They're usually set up, especially if it's on the regions, they're set up to be solved a certain way. So how do I know this one is set up for substitution? If you're going to use substitution, you have to be able to get one variable, either x or y, by itself really easily. So I have four variables here. I have x, I have y, that's in the first equation. I have x and I have y in the second equation. Is one of them almost by itself? Okay, this x is not almost by itself, it has a 3 attached to it. This y is not by itself, it has a 2 attached to it. This x is almost by itself though. I can so easily get this x by itself on one side of the equation. All I have to do is move that 3y to the other side using the opposite operation. So I'm going to subtract 3y from both sides. And what makes this tricky is that it's not going to combine with the 5, it's just going to be right next to it. So this zeroes out, I'm left with x by itself, and x is equal to, and I can say either negative 3y minus 5, or I can say x is equal to negative 5 minus 3y. Both are correct. It doesn't matter which one you want to use. I just have to remember I can't actually combine those two and get like negative 8. Not equal to negative 8y. All right, so now that I've isolated x, now I have x by itself. So I can say anywhere I see the letter x in the first equation, so I'm gonna bring this first equation and just bring it down here so I can work with it. So I have 3x plus 2y equals 6. And now I have these two equations that I'm working with. Anywhere I see the letter x, I can replace x with this expression. So I see the letter x, I can replace this x with that expression. That's the substitution. So I'm gonna go 3. Instead of x, I'm gonna replace x with what it's equal to. X is equal to negative 5 minus 3y. So I'm gonna put negative 5 minus 3y, close it up. Now I'm gonna continue, plus 2y equals 6. Now I have one equation and I only have one variable. Now they're both y's. I can solve for y. I can figure out what y is equal to. And that's what I'm gonna do. All right, so I have this equation that I'm gonna solve as if it were just one equation that I was solving for y. I'm gonna start by using the distributive property because that's always what I do first. So I have 3 times negative 5, which gives me negative 15. I have 3 times negative 3y, which is equal to negative 9y. This stays the same, it's not in the parentheses, so I just put 2y equals 6. I just copy it down the way that it was. Okay, now I'm gonna go through and combine my like terms. I have negative 9y plus 2y. Those are like terms because they both have a y on them, so I can combine them. So this negative 15 stays negative 15. Negative 9 plus 2 is negative 7y. That's those two combined to give you that. And it's still equal to 6. So now I have a two-step equation. So now what I'm going to do is start to get y by itself. I'm going to put a line through the equal sign, and I'm going to move my constant first to the other side using the opposite operation. So I'm going to add 15 to both sides. This zeroes out. I'm left with negative 7y is equal to 21. The next thing is negative 7 is being multiplied by y, so I have to divide both sides by negative 7 to get it to the other side. Negative 7 divided by negative 7 cancels out, you're left to negative 3. Now this is only half of my answer. Okay, I need an ordered pair where I have an x and a y value when I'm solving a system. So right now I have my y. I have y is equal to negative 3, and I don't know what x is equal to. So how do I figure out what x is equal to? If you recall, I had solved this equation a while ago where I said x was equal to negative 5 minus 3y. Well, now I know y is equal to negative 3. So I can replace this y with negative 3 and solve for x. So this is the same thing as x is equal to negative 5 minus 3 times negative 3. You could type this into your calculator or you can solve it one step at a time. You always have to follow PEMDAS. So first you would do negative 3 times negative 3, which would be positive 9. That means x is equal to positive 4. So that means you have the ordered pair 4, negative 3. This is your solution. It's a good idea to always confirm your solution is correct, so I'm going to do it graphically. I'm going to type in the first equation on this Desmos calculator. If I press enter, I can type in the second equation on the same calculator, and it'll show me exactly where the two lines intersect. Now that point of intersection is the solution, and when I hover over it, it tells me the ordered pair is 4, negative 3, which is the same answer I got algebraically. So to recap here, I was given a system of equations. I knew it was a system because I have two linear equations with two variables, x and y in this case. I started off by identifying which variable would be easy to isolate, and I determined this x would be easy to get by itself. In order to get that x by itself, I decided to move the 3y to the other side using subtraction. So I subtracted 3y. I got x was equal to negative 5 minus 3y. I then took my first equation and I lined it up. I said 3x plus 2y was equal to 6. And I said anywhere I see the letter x, I can replace it with this expression. And I was like, there's an x, I'm going to replace it with that expression. I then rewrote the equation as 3. Instead of x, I replaced it with negative 5 minus 3y. And I put plus 2y just to bring down what was left of the equation equals 6. I then solved that equation like a one-step equation. I first distributed. I got negative 15. I got negative 9y plus 2y was equal to 6. I then noticed I had some like terms that I had to combine. So I had negative 15 minus 7y was equal to 6. I then noticed I needed to move the 15 to the other side using the opposite operation. So I added it since it was negative. Since that zeroed out, I ended up with negative 7y was equal to positive 21. The last thing I needed to do was divide both sides by negative 7. I got 1y was equal to negative 3. That was only half of my answer because I needed an ordered pair x and y. I so far had the y, but I did not have the x. So I then took this and I went back to the top all the way to this equation that I created. And I said, well, now I know that y is equal to negative 3. Let me plug that into this equation. So I have the equation x is equal to negative 5 minus 3y, but I know y is equal to negative 3, so I'm going to replace it. X is equal to negative 5 minus 3 times negative 3. When I type that into my calculator, I end up with x is equal to 4. So I end up with the final answer of 4, negative 3.